So question 4 on problem set 1 is probably one of my favorite questions that I use every year I teach this course. So the question is, which of the following will react faster in SN1 reaction? Explain in detail. And I went over this in lecture, but I wanted to make a video of this so that everybody would have it to study from. So the first thing that you need to do is draw the right chair conformations of these molecules. Alright. Remember, the tert-butyl group is going to lock that cyclohexane group into this particular chair conformation. And then, so the question is, how do these react in an SN1 reaction? So one thing to recognize is that these will have an identical intermediate in that SN1 reaction. And the identical intermediate in that SN1 reaction is this. That carbocation at that position. So the answer to this question is going to lie in how do these two different substrates get to this carbocation intermediate. And the thing to recognize here is that this molecule with the bromide in the axial position is higher in energy than this molecule. So I'm just going to arbitrarily name this 1 and this 2. So if we were to set up a reaction coordinate diagram, 1 is going to be higher in energy than 2. And they will have identical intermediates, which is that carbocation. I can draw it like this. So if you draw a coordinate diagram, and then we'll go to whatever the product is. Okay. So what's important to realize here is that the activation energy for 1 is smaller than the activation energy for 2. So 1 reacts faster because it's in a higher energy state, so there's less energy to get it to this carbocation intermediate. All right, so this one reacts faster.